Of a friend that has moved from various languages and she's so totally confused right now. Do you understand? So focus on something. You can know all things. Yeah, you can know all things, but become a master of one. Do you understand? Become a master of one. If you should wake me now in the middle of the night and ask me something in data science, in fact, I would tell you without blinking my eyes. Let me give you a scenario. I went for an interview and the interview was with the MD. And the MD, he knows nothing about data science, knows nothing about analytics. And he called some software guys, some software engineers, okay? Of a friend that has moved from various languages and she's so in my own field right now. Do you understand? Software engineers something in my own field. Now, this software guys, you can know all things. They've read one manual. Yeah, you can know all things. Become a master. They've read one manual about data analytics. They've read one manual about scikit-learn or about PyTorch or about Tableau, about Matplotlib and whatever. And they were asking me questions in my own field. I mean, the interview got to a certain level where I was schooling them. I don't know if you understand. It got to a level where I was schooling them. Even got to a point they were saying things that were not in data science. Probably they read one blog somewhere, and blog can be so very confusing sometimes. Probably they read one blog somewhere and I was like, no, it is not like this, it is like this, it's not like this, like this. Why? Because I have mastered my art and craft. They just know what they know. Probably they've read it somewhere, they've not applied it. Me, I have applied it, I know how it works. Do you understand? So what I'm trying to tell you now is, become a master of one, and nobody would ever bamboozle you. Trust me, nobody would ever trick you. Okay, so let's just, I don't like going to slides here, but now, understand how to learn the language. The basics is very important. The basics are the building blocks to greater programs, in quotes. Understand how to learn the language. Now, there's a difference between learning and learning how to learn. Hello? There's a difference between learning and what? Learning how to learn. I'll give an example. I said I studied statistics while I was in school, and I was already exposed to different data science terminologies, like regressions, like clustering and what have you. I learned it, but I never learned how to learn it. I don't know if you understand what I'm trying to say. I was already exposed to it. They taught me. We're just doing it with our hand, theoretically. I knew it, but I never knew it in depth. I never knew what was going on under the hood. I mean, when I call a particular class, I don't know what is happening. Do you understand? It was when I now moved into data science, I now learned how to learn it. So there's a difference between learning and what? Learning how to learn. I can pick up a material and just glance through and read through. If you should ask me something in that material, I will tell you. But by the time you start dissecting it into depth, I might be lost. So there's a difference between learning and what? Learning how to learn. Python is very crazy and very tricky. Very crazy and very tricky. The basics which you think you know, the basics which you think you know, trust me, you really don't know. I'll give you an example. We all say Python is fast, Python is fast, Python is fast, but have we really asked ourselves, how fast is Python? What really happens under the hood when you perform a particular action? For example, I have a variable, a is equals to 5. I have another variable, b is equals to 5. I perform a simple operation. I say a double equal to b. It gives me true. Yeah? It returns a boolean, true. And I'll say a is b. It should return a boolean. Yeah? Have at the back of your mind that a is 5, b is 5. I've checked if they are equal, yes. But is A actually B? No. Why? They are different. How are they different?
Because when you say the concept of a baby is just a memory location.
Okay. Yeah.
So when you say A is B, just like saying, even if they are two languages, just like saying this language is that, they are different entities.
Okay.
So they contain the same thing, but they are different entities. So
okay.
In the concept of complexity, so they are different memory locations, so they are not the same.
God bless you. Now he understands the basic. He understands the what? The basic. That is the basic. A beginner would say that, but 5 is 5. Do you understand? Memory-wise, both of them have different memory addresses. Do you understand? Both of them have different memory addresses. They are identical, but they have different addresses. Do you understand? So know what is happening under the hood. Know what is going on. Don't just know how to use things. Don't just know when to use things. Know how those things work. They would help you a lot. If you know how they work, they will help you a lot. And the funny thing is that Python has this helper class or this help function that makes you know what is going on. Do you understand? So a very simple example is, like he said, I just wrote that example out. So, every language, every programming language, be it Python or whatever. No, don't worry, I will explain it, don't worry. Okay. Every language, as long as it's a language, it must be read and it must be written. Meaning that you must know how to write it and you must know how to read it. Hello? You must know how to write it. You must know how to read it. I mean, we all speak English language, yeah? And we all know how to speak it. We all know how to write it. Same thing also goes for Python. If you want to be a Python developer, you must know how to read it. You must know how to write it, irrespective of whoever has written it. Meaning some people have, pardon my French, shitty codes. Do you understand? Some people have very funny looking codes. But as a Python dev, you must know how to interpret it. And not just interpret it into details. Know what is going on. Do you understand? Know what is going on. Now, there's a very simple example here. It says A is equals to -5, B is equals to -5, A is B, A is equals to B, A is B. Now, these two will return different answers. Why? Because the memory addresses of this guy is different. Now, if you want to know the memory address, you just put ID of A and ID of B. You would see that different address location. Do you get me? Now, I said, at this point, okay, E is equals to this guy, E is equals to this one. At E is equals to F, what should it return? At this part, it should return true, yeah? At this part, it should return what? Why? It's the same thing. Now, there's this concept of being interned. What Python does is that common numbers between -5 and 256 are reserved in the same memory address. They are reserved in the same memory address. Because why? Those are numbers that are often used. Python see those numbers are frequently used numbers. Do you understand? Between -5 and 256, they are entered on the same address. Anything above that is a different address entirely. Do you understand? So the same thing also happens to this guy. Okay? The baseline is understand the nitty-gritty of the language, especially when it comes to saving memory. Saving memory. Know when to use a for loop. Know when to use an if else. Know when to use a generator. Know when to use a decorator. I mean, my devs, we all know what generators are. Hello? What are generators, please? Someone help me out. God bless you. That's just the perfect answer. That is just the perfect answer. Generators use numbers. Okay, but they don't save that number to memory. Do you understand? Now, when you write a function and you return something, that thing you are returning is being saved to memory. But for generators, they don't return, you yield. Just like he said. So know when to use, there are so many concepts. Know when to use a try-catch expression. Know when to use lambda expressions in terms of, in place of functions. Know when to use ternary operators. Know when to use decorators. Know when to use generators. The concept is just so wide. As simple as the language is, it's very wide. Know when to use these stuffs. Okay, now there's a simple example here. I demonstrated. Okay, you expanded it. Okay, now there's a simple example here I demonstrated. Yes, know when to use. Okay, before I move on to that part, what is the difference between? I know we've seen it in functions. What's the difference between star args and double star quags? Have you seen it before? Star args. I know you guys might not have seen it before, but I'm talking to the Python devs now. Star args and double star quags. Yes, I know one is keyword argument, the other one is normal argument. So when do you use it? How do you use it? You see what I'm trying to say now? Understanding the basics. He knows that it is a keyword argument. He knows the other one is just an argument. You see it in people's function, you see it in people's code, and you keep wondering, okay, what is going on here? You know that they are passing something into a function and they are returning something.
I think star arg means the arguments can be as many as possible.
Okay. And it returns what? It returns something. Positional argument. Now, positional arguments are those arguments you yourself have specified. Do you understand? Positional arguments are those arguments you have specified. Yeah, you were saying something. Okay, forget what it returns. Then what of double star quags?
Double star quags.
That is keyword arguments. Yeah.
Keyword argument.
Yeah. Okay. Now you see that what I'm saying. He would have seen that so many places in someone's code, and probably they might not have written a documentation, okay, on that function. I'd be like, okay, let me just skip it. At least I know what is returning. You're already lost. Do you understand? Know the nitty-gritty. Now, star args and double star quags. For conventionally, that is just Python technical terms. Args and quags can be anything. It can be star Franklin and double star Franklin. It can be anything, but it's just convention. Now, just like he said, you have a function. Your function wants to receive parameters. Say it wants to receive 10 parameters. Do you understand? Now, do you start putting the parameters in that function? So, for example, you say def, the name of the function, parameter 1, parameter 2, parameter 3, parameter 4, parameter 5, parameter 6, parameter 7, parameter 8, parameter 9, parameter 10. If I see that, I'll know that you're just learning. That is where star args comes into play. So star args can receive n arbitrary numbers of arguments. So when I put star args in my function, I'm free to use 1 billion parameters on that function. Okay? And it returns a tuple. Do you understand? It is a tuple. Double star quags. Keyword argument. That one receives a dictionary. It's the same thing with star args, whatever number of arguments you want to receive. Do you understand? But what that one returns is it returns a dictionary. Do you get? Understand? You were saying something? Yeah. Yeah, star quags. That's what I said. Star quags. Do you understand? But technically, that is just Python convention. It can be anything. It can be star bincom, star bincom. The keyword there is the star and the double star. Understand the basics. So there's a simple example here in terms of star args and star quags. So I have a function here that returns the sum of two numbers, and I'm using the conventional method to position. Like you said, these are positional arguments. Okay, positional arguments A and B. So what happens if I wanted 10 parameters, 20 parameters? Do I keep saying A, B, C, D, E, Do you understand? It doesn't make sense. So Python came up with a conventional way by using star args. So that is it. It's the same thing here. Star args. Okay. Now this example here shows when to use a generator instead of using when to use a generator in a function. Now this one is not a generator, this is the generator because why it is yielding a particular number. Now I'm using for I in range of n result.append blah blah blah. Now what this one does is that Sorry, it's not a Python class, but I just want to use to explain. Now, what this one does is that for every time I perform that action, that's for every time I perform this, yeah, for every time I perform this, it appends the value of A to my result and saves it in memory. It performs my value of A and saves it in my memory. Perform my value of A and saves it in my memory. Questions. What if I were dealing with a very, very large number? For example, 1 million. What happens? That means I have to go to Sabo and come back, and it's still running. Do you get? I have to go to Sabo and come back, and it's still appending this result. This one is taking up my memory, it's eating my memory, and I don't know when I put this on live or something, I don't know the memory space of the server or something. Do you understand? But this one, it is not reserving it in memory. As it's getting it, it's dumping it somewhere. As it's getting it, it's dumping it somewhere. As it's getting it, you are seeing this one per time. So imagine I run this one and run this one, and check out the time at which both of them execute. This one takes a very shorter time. Do you understand? What I'm trying to say is, understand the basics. Learn to learn the basics. Do you understand? Python has this very, very efficient method of trashing stuff they don't need. I don't know if you've heard of garbage collectors. Hello, Python devs. Garbage collectors. You've heard of it. As in, it is very wide. Don't just know list dictionary tuples and say, oh, I'm good. Don't just know don't just know your conditionals and your loops and say, oh, that's perfect. Okay? It doesn't work like that. There is still so many things going on. So many things going on. So that's for that. Know and understand the basics. No, but the second one is code every day. This might sound very hard, but they say, how do they put it? A journey of 1,000 miles starts with the very step. Yeah? Code every day. Code every day. Start little. Don't rush yourself. Just start little. Max 25 minutes a day. Max an hour a day. Code little. And start little. And trust me, okay, when you start, it doesn't work like that. There's still so many things going on. So many things going on. So that's what I definitely know and understand the basics. No, but the second one is code every day. But this might sound very hard. Practice makes perfect. But they say, I was reading something the other time. They said if you want to be a professional at something, you must spend at least 10,000 a journey of 1,000 miles. Mastery, that's the very step. Coding every day would definitely help you. Every day. It might be very every day. Start little. Don't rush yourself. Just start little. Max 25 minutes. It might be very cumbersome. An hour a day. But code little every day. Start that. And trust me, when you code every day, it doesn't work like that. At the point of coding every day, you tend to run into so many things. You tend to run into. So that's what I definitely know and understand the basics. No, but the second one is code every day in that process. But this might sound very hard. Code every day. Then one I was reading something I love doing is writing it out. You must spend so journey of it. Writing it. Write it out. Coding every day would definitely help. It might sound stupid, yeah, but write it out. I have 60 leaves nonsense. To an outsider, it might be nonsense, yeah, but I still do that. I have my notes. I have my notes from web dev to software to AI to machine learning to data analytics to even to the most useless thing in Python. I have notes. Write it down. Research has shown that things that are written down, you don't forget it. When you write things down, you don't forget it. Mr. Bade normally says something. If you are going for a meeting, go with a paper, go with a book. I don't know if you guys still do it. Oh, you just go for meeting and just go for meeting. I know. Go with a book. Write it down. Okay? If you are a web dev or you're a software dev or just a Python developer, make sure you have a blueprint of what you want to do because it gives you time to arrange your code, know how stuff interact with each other. It gives you time to create the structure of your code. When I want to code, I don't just sit down and code. I've already written down. Research has shown that things that are written down. They say something. They say you don't forget. Every code starts with a template. Or the very first line, which can be Mr. Bade normally says something. If you are going for a meeting, do you understand? Paper. For you to want to I don't know if you guys still do means that okay, you must have written just go for meeting and just when I write my codes. I know. I don't import a book, libraries I need to use after okay. If you are a web dev or a software, do you get me? Or just I don't import libraries I want to use. Make sure you have the when I'm online what you want to do because it gives you time to I must have arrange your code, know how I'll perform this action, I'll perform this action, this function interact with each other. It gives you time to create the structure. I need to do something here. When I want to code, I don't just sit down and follow them precisely. So research has shown make it and habits and okay. They say something they say somewhere. You don't forget. That you can always make reference to. It's not every time you would be online. Or check the very first line. Do you understand? Mr. Bade normally says something. If you are going for a meeting, do you understand? That's for you to want whatever. Then the next one is be interactive. Like I said, when I write my code, I know. I don't import the very write that down. Interactive. Okay. Know your type of elements. Know how to using built-in help documentation. You don't need to be going online to check pydocs.com every time. You know. Be very interactive. Use the interactive shell. Help.strings will tell you whatever actions you can perform on a string. Help list will show you whatever actions you can perform on a list. Do you understand? Be very interactive. One thing, again, import libraries and play with them. Import libraries and play with them. Ibrahim was so very particular about writing your own libraries, writing your own modules, writing your own packages. The truth of the matter is, yes, that's the truth. The truth of the matter is, when you see a need to do that, you do that. I'll give you an example. Okay, before the example, there's something we need to know as a Python developer. For every script you have written, or for every program you have written, please, I beg you in the name of God, know how to write a test. I don't know if it makes sense. Know how to write a test. Why? Because when you write a test, it makes you know if your code would eventually run on whatever platform you want to put it. Know how to write a test. We don't do that. What most people do is that they write their code and they give it to a software tester to test for them, which you can do it by yourself. To the littlest function I write a test for it. So I don't have to start trying numbers or trying data to test what I want to test. All I need to do is just to run my test.py file or run whatever .py file I've written as a test. And if it can run on development, it will definitely run on production. I'm sure of that. I don't need to say, okay, help me test this thing. What if I know how to write a test? Okay, so I was saying something about importing libraries or building your own libraries. Building your own libraries comes as a result of a need. For example, while I was still working here, I don't know, probably Python devs must have seen it on their server also. While I was still working here, probably must have worked on it one time. There's a file called connect on your server. I don't know if you guys are still using that server. You've seen that file? There's a file called connect. For every code we've written, you will see import connect. Now, connect is not a Python library. We built that library. What does the library do? The library just checks the environment of dev and master. What environment you are trying to run a particular code. If it's on dev, it is on master. Do you understand? There was a need for that. For every code I want to write, I don't need to start writing login credential for dev. I'll come down and write login credential for master. I'm wasting time. I would have just written that as a file somewhere, save it on the server, then import it anytime I wanted to use it on my script. Do you understand? So the need for writing your own particular library, the importance of writing your own particular library arises based on the fact that there's a need somewhere. If you're very familiar with testing, very familiar with testing. There is a particular library on Python. There's a particular library on Python called HTML Test Runner. What that library does is that it gives you a graphical representation of your test results. Okay, as at present now, that library is not working. As I'm talking to you now. In fact, if you pip install the library, you can't even use it at all. If you pip install the library and import the library to tell you that module is not found. So how we use the library is you download the file and save it in your Python path or whatever. Now, I decided on my own, because I needed that particular library, I decided on my own to debug that library. There was a need. I don't want to use any other reporting tool for me. I needed that HTML tester now. Okay. Now I found out that library was written in Python 2. Hence, there's no way it would run on Python 3 or Python 7. I mean, why would you be telling me if something dot has key is not specific to Python 2, for crying out loud? Do you understand? So many classes and so many functions are way out of line. Currently, I'm working on that library now. Do you understand? And how am I working on that library? I wrote my tests, I ran the codes. I'm saying, okay, there's an error here, there's an error here. I read every feedback I get from whatever the code is giving me. And I try to fix my bug. Okay, you have XYZ on line 623. I go there, I check it out. Okay, what is happening? This function is calling this function. Okay, I'll go down. Okay, why is this function calling this function? What did this function call this other function? Ask questions. Don't worry, we'll get to that part where we ask questions. Okay, ask questions. Now, when I'm done with that library, I would push it and it becomes open source. I will also get to that part where we'll contribute to open source too. Okay, so run shell commands. Shell commands are very, very important. Run shell commands. Improve your problem solving skills. Trust me, this would help you. It has really helped me a lot. How has it helped me? I've gone for interviews, I've gone for meetings where they give me a whiteboard question to solve without my laptop. And you just have a marker and start solving it. Without your laptop, no interactive shell, nothing. You're not running the program on your laptop, just a whiteboard. Google does that a lot, whiteboard interviews. Improve your problem solving skills. How do you do something so well? You practice. It must be a gift from God. Practice. Practice makes, they say perfection, they say perfect, I don't know. But practice does something. It brings perfection into life. Practice your problem solving skill. Codewars.com, they're always dishing out problems for people to solve. As not important as Sudoku is, it will improve your thinking ability, it will improve your logical reasoning. Please, I beg of you, don't cram algorithms. Please, don't cram algorithms. If you see an algorithm online, don't cram it. Please, it won't help you. Don't cram algorithms. Instead, know what is going on and you can write a better one. I love reading people's codes. That's one. I love reading people's codes and I love debugging. I can write an algorithm in 5 different ways. Once you understand the concept, you will replicate it in different dimensions. Don't cram codes. It's not ideal. I was reading an article, and the title of the article says 10 algorithms every programmer must know by heart. And I'm like, okay, if every programmer should know this algorithm by heart, it means that if I should go to London, it will still be the same. I need something different. Please do not cram algorithms at all. Please, please. I beg of you. It wouldn't help us. It wouldn't. So improve your problem practice skill. Practice coding problems on a site like codewars.com. Get a book of logic, blah, blah, blah. Work on defining problems instead of thinking of solution. I like this part. This particular part. Why I like it is that it is relative to data scientists and data analysts. There's something we call business problem definition. Define the problem, first of all, before thinking for a solution. If you can know the problem, in short, you have solved it. If you can know the problem, you have solved it already. So instead of looking for solutions, define the problem. Define the problem first of all. Write it down. Okay, now get curious by asking good questions. Remember, there is nothing like a dumb question. No question is dumb. So your definition of good questions is you give context of what you are trying to do, clearly describing the problems. You have a problem. Someone wants to help you. Define the steps you have taken or describe what you are trying to do. Clearly describing the problem. Now outline the things you've already tried, fixing the issue. There must be so many things you must have tried before you fix the issue. Okay, now offer your best guesses as to what the problem might be. Try as much as possible to guess what the problem might be. Then demonstrate what is happening, include the code, and track back messages. Okay, that is the definition of a good question. So the first thing you have to do is to give context on what you're trying to do, outline the things you have already done, offer your best guesses as to what the problem might be, then demo what is really happening. Then one thing again I would say is surround yourself with like-minded Pythonistas. Attend events, please. It is important. Attend events. Connect with people. LinkedIn, Instagram, Facebook. If you check my LinkedIn profile, 90% of my connections are into data science and data analytics. And we share ideas. We help each other. I can't count how many people I've helped on LinkedIn. I can't. So surround yourself with like-minded Pythonists. Attend events, Python events. Attend it. You don't know who might help you there. Trust me, you're going to learn. You will definitely learn a lot. Yeah. Peer programming. Peer programming is very important. I know Python. I know most of us would want to write our codes alone, and like me, yes, I love being to myself when I'm coding. But at the same time, I engage people that are like-minded like me. Okay, there's something we call the driver and the navigator. Okay, so the driver writes the codes, and the navigator kind of shows you. Okay, I remember, when we were still upstairs, while I had someone that I was looking up to, while he was writing the code, I was always sitting by him and trying to point out, okay, boss, what if you did this like this? What if you did this like this? Do you understand? Peer programming is very important. You don't know everything. Do you understand? So engage in what? In peer programming. Okay, now teach what you know. In fact, it said that the best way to know what you know is to teach what you know. Try as much as possible to teach what you know. Teach what you know. Okay, when you teach, you tend to know more of that thing. I mean, I've engaged in various Python tutorials, online, offline, on-premise, off-premise. I can't count. Teach what you know, even if it's what you just learned today. If you just learned least today, trust me, there's always someone that is looking for that idea. Teach it. When you teach it, you would know more. You will understand more. Okay? Now, be a fixer. I love this part. I'm always looking for bugs. I love finding bugs. Oh God, I'm a bug hunter. I love looking for bugs. That's my specialty. I like finding. JT, you're shaking your head. I know why you're shaking your head. I love looking for bugs. Fix bugs. When you fix bugs. Fix bugs. When you fix bugs, you tend to understand things more. You tend to know what is going on under the hood. Learn to be a fixer. Debugging is important to have methodological approaches to help you find where things are breaking down. Go through your codes in which it is executed and making sure its part works is a great way to do this. Now, one way to fix a bug. One way I fix a bug, let me not make it general. One particular way I fix my own bug is I break my whole codes into simple, tiny Bits and pieces. That is the best way. I break my codes. If I have 1,000 lines, 2,000 lines, I break them into bits and pieces. And I try as much as possible to print out fail. He will fail. So break it down. Where you need to print what is happening, print and see what is going on. Okay, from line 1 to line 5, I printed this. It gave me something. Okay, line 1 to 5 is working. Okay, what of line 6 to line whatever? Okay, print something out. Okay, it's working. Line whatever to line whatever. I do that a lot. Okay, break your code into bits and what? And pieces. Then the next one is build something, anything. You've learned the language, you've understood how the language works, you know how memory is being conserved. Build something, anything, to show that you really understand. Build anything. It could be a calculator app. It could be a weather conversion app. Build anything. Build anything. I remember when I was still learning how to use Tableau. When I was learning how to use Tableau, oh my God, I would always jump at every data set I see. Any data set I see, I would always want to tell a story from the data set by visualizing it. It will afford you the opportunity to know what is happening. Do you understand? To afford you the opportunity, no matter how small the data set is, no matter how large the data set is, I always wanted to know, to give a visual representation of that particular data set. Build something, anything you know. If you've just learned how to use Django, build something. If you just learned how to use Flask, build something. If you just learned how to use any of the machine learning libraries, PyTorch, TensorFlow, Scikit-learn, build something, jump into a data set. Try to, yes, you would run into problems, but when you run into those problems, you will definitely find your way out. Build something, anything is very, very important, anything. All right. Now get familiar with ORM libraries, object relational mapping libraries. Now using and connecting applications through an ORM like SQL Alchemy, Django, ORM, and so on is easier and faster to use than just writing queries. Okay? It is faster than just writing queries. And even if you don't know how to use any of these ORMs, please, Python is an OOP, is an object-oriented programming language. Let us make use of that concept. It is faster. You can write your SQL queries as a class. Yes, you can. It's very, very possible. You can write your queries as a class instead of writing pure SQL queries. If you should write pure SQL queries, what happens tomorrow if they change something on the database? What happens tomorrow if they remove a particular column or a particular column is dropped? It means that all the stuff you've written out is useless. Write it as a class. Make use of the concept of OOP. So ORM is very, 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 very important. Now this is particular, no, not really particular to software devs and web devs. Understand basic front-end technologies. Please, it's very important. It is very, very important. At the point where you are using your Django, you might want to call in a bootstrap file. How do you do that? So now you have to go to a front-end guy now, and they start. Come on, learn how to use these guys. Basic front-end technologies. Learn how to use that. It will really help you. Know how to build. Yes, I didn't put that. Know how to build APIs. I mean, if you don't have an AWS server or a GCP server where you can always push your code to. Okay, I'm speaking in respect to machine learning now. You've created your model. Your model is working perfectly on your machine, on your local host. How do you demonstrate it to your client? Your client might necessarily not have an AWS server or a GCP server. What do? You've created your test split. You've created your training set, your test set, which is your new data. Do you show your client the